Alright, this is hopefully my mic is working. I don't have headphones, so I can't listen to myself speak. Um, I wanted to make a video about this, but I figured it's just easier to do this live, so that way people can just rewatch this whenever they need to. So, for those who are tuning in, welcome everyone to the stream. Happy to have you all here, and what we're gonna do is we're gonna set up microservices in Nest.js. This is actually really cool. I spent some time working on this and doing some research, and I was able to set something up that I think that many of you will find extremely interesting and very useful when you build large scalable applications. So we are going to be using Docker for this. So I'm on Windows, so it shouldn't be too big of a deal because it works fine. Well, let me just open this up. So, okay. Here's what we're going to do. So I have a diagram over here that I want to show you all. So we're going to have an HTTP API that's going to take in GET requests, POST requests, things like that. And it's going to send messages to a NATS server. So if none of you know what NATS are, let me show you this website, NATS.io. And this is all new to me as well. But pretty much it allows you to create, like a pub sub type of system where you can publish events to a bunch of different subscribers, if you think of it that way. So with NATS, it's super powerful because you can send events to a bunch of other microservices that are connected to the NATS server. And it makes it very useful and kind of like allows you to communicate between different microservices, if that makes sense. So if you look at this diagram over here, you'll send messages to the NAT server, and then the NAT server can send those messages to whichever microservice you need to. It is done a little bit differently in Nest.js, so I will say that, because the way that I'm used to setting up microservices outside of Nest.js was done differently, so it really just depends on the framework you're using. Okay, let's see. So we're going to set up a couple of projects, and then all of the code will be on GitHub. So after this stream, once I'm done with it, I'm going to put all the code that I'm writing, everything that I'm doing inside a GitHub repository, so that way you all can use it as a reference later. Because I think that this is going to be super useful and helpful for a lot of people, in my opinion. But yeah, if you're just joining right now, welcome to the stream. I see all of you chatting. The stream, I'm gonna try to keep this under an hour, maybe under an hour and a half, because it's such a large topic. It's such a large topic, so I will try to keep under an hour and a half, and then I'll kind of like do some editing whatnot, and then add it in my Nest.js playlist so people can reference it later. Okay. All right, let's get started because I'm sure everyone's looking forward to this. So what we need to do is we need to set up this root API. Okay, so we need to set up this root API. This API is going to take in HTTP requests, and it's also going to connect to the NAT server. So we kind of are going to use this API as a gateway into all of the other microservices. So I'm going to go into my PowerShell, and I'm going to create a folder, and I'll call this, let's see, Nest.js microservices. Okay, so we have Nest.js microservices. Let me open up VS Code. I hope you all are doing well, by the way, for those who are just joining in. All right, so this is going to be our root project. So like I said, this whole repository will be uploaded on GitHub, so you all can use it as a reference. So what I want to do is I want to set up a couple of projects, but the first thing that we need is the root API. So I'm going to do nest new root. Let's see, root Nest.js API. So when I refer to root, I'm talking about the root Nest.js API. So we're going to set up this project, and then we're going to set up 2 to 3 more Nest.js projects that will each be our own individual microservice. Okay. So let's just wait for it to finish installing. And the other exciting thing is that we will be using Docker as well to containerize everything. And I think really it's the best way to do this because it allows you to just install a bunch of services that we will need, such as the NATS server, without needing to actually install it onto your system. You can install on your system if you want to. I would prefer to just use Docker and keep everything containerized. Okay, so I just created the Nest API. We're going to create 2 more. So I'll follow my diagram that I have here. So we'll create a user's microservice, and we'll do payments. We'll just do 2. We won't do the third one. So let's go back here. So we'll do nest new, and I'll call this user's microservice. And it'll be the same thing, npm. Okay. I could probably generate the other one on the other tab just to save some time. Nest new payments microservice. And it's already done already. Okay. While that is being done, I will need a Docker file for each one of these projects. So I'm just going to copy a very simple one that I used. And like I said, you guys can just use the code that I upload on GitHub as a reference. I'm not really going to explain too much with the Docker file, because it's just very simple. And I assume some of you might already know about Docker and know how to use it. But this is just a very simple Docker file that will use Node version 18 and then install the dependencies. We are going to use Docker Compose as well. Let me do this. Okay, so I have this Docker file. I need it in root and users microservice. So I'm just going to copy and paste it in here, and then paste it in here. Okay, and that's all we need. We're going to use Docker Compose file to expose the port and run our necessary commands. So let's go into, let me go back here and close this. Okay, so I have my 3 projects. I have the root API. I have 2 of my microservices. And now I need to set up the Docker Compose file so we can actually get all 3 of our applications running. And we're also going to set up the NATS server as well as a database. So I'll be using SQL because I personally like using SQL. So I'm going to create a new file called dockercompose.yml. And then I have this on another screen, so I'm just going to kind of go through it real quick and explain to y'all what I'm doing. So I'm going to define all of my services. So we'll do each one of our APIs is going to be a service, of course. So I'll do root API is the name of our service, and we're going to tell Compose to build root Nest.js API. Okay. We're going to expose the port. For this port, I'm going to run it on port 3000. So I'm going to use the Docker host port as 3000 and map it to the internal port 3000. So our app is going to actually run on port 3000. I'm going to actually attach a volume onto this. So that way, whenever I make changes, it will auto reload. So I'm going to do root Nest.js API source, and then /users/source/app/source. And like I said, you know, I don't want to like explain what exactly all this stuff is because some of you already know what's going on with Docker. But just know that this Docker file, all the Docker files in the Compose file will be in the GitHub repository. So you can just bring that down and run it. And of course, it's different for everyone. Like some people want to tailor it to their business needs. So that's why I don't want to like be so fixated on one single configuration. So what I'm going to do is I'm going to have it run this command, npm run start dev. So this will run the start dev command in the package.json file right here. So we're going to run in dev mode. And then I'm going to set an environment variable for the port. So for this, it's going to be port 3000. And we're done with the root API service. And I'm going to set up the service for payments and users microservice. So users microservice. And it's just going to be pretty much the same thing here. So I'll just copy all this and change up the references. So this will be, instead of root, this will be users microservice. And I'm going to replace this with this right over here. And then the port will be different. For the port, we probably actually don't even need a port for this because the microservice is not going to take in any HTTP requests. They're going to be using NATS protocol to be transferring data. So we probably actually don't even need this. I'm going to remove that and remove this. And let's see. I think that is... Yeah, I think that's it for that. So I'm going to copy this and do the same thing for payments microservice. And then just change this to payments microservice. Okay, cool. So the other two things that we need now is we need to set up NATS. So I'm just going to define this service as NATS. And then I'm going to specify the image. So it's going to pull the NATS image from the Docker registry. And then the port that I need to expose is, let's see. 4222, 4222. By the way, for some reason, I just saw these messages now. I don't know why my YouTube chat on the browser is not showing your messages, but I apologize for not seeing your messages. Let's see. Sleepy Boy. Hello, how are you? I am Huang. It's been a while. Nice to see you again. It's been a year. Herbert, how are you? Luke Pryor, nice to see you again. Ocean Man 44, hey man, I just wanted to let you know I followed your Express tutorial, making my software engineering final project. And I thank you for being a good teacher. Thank you so much, Ocean Man. I appreciate it. Hi, Sleepy Boy. Yeah, I'm just seeing those messages on the other screen, so I apologize for not seeing those earlier. Okay, so I have my NATS set up, and then now I'm going to set up MySQL. I'm just going to copy what I have in the other configuration. So we're going to name our service for MySQL, MySQL_DB. We have the image right over here, and then we have the port. So I actually have MySQL server running on my computer on port 3306. So that's why I'm actually setting the port to 3307. So that way it doesn't conflict with that. And then I'm going to configure the environment variables for MySQL. So when it spins it up, this will be the root password. I'm going to use this database name, and then I'm going to also configure a user and a password as well. Okay, so we're done with the Docker Compose file. So what I'm going to do now is this. I'm going to go into the root API, and I'm going to go ahead into the app controller.ts file. Or I'm sorry, not this one, the main.ts file. And I'm just going to go ahead, instead of hard coding the port, I'm going to do process.env.port. And of course, if for whatever reason if this is undefined, we will just set this to port 3000. Okay, so we have the root API listening to requests on port 3000, which is what we want. And I'm also going to write a console log. Oh, actually, let me do this. Process.env.port. And then console log. Okay. So we have our root API running on port 3000. Okay, this is the root API currently. And it might seem confusing because we have 3 Nest.js projects and all the files are going to look the same. So that's why I'm going to reiterate, which project we're in, so that way people understand what's going on, because I understand that the file structure, everything is all the same, and it can be pretty confusing. Okay. So what I'm going to do is this. I'm going to delete all of these controller files. So let me delete the spec file. I don't need that. I'm going to delete the service. Don't need that. Don't need this. Okay, let me remove that. Okay, so we're good with that. So just cleaned up the root API file. Let me go and do the same thing for payments microservice, because we're going to recreate these files, but for the payments microservice. I'm going to delete this, delete the service file, and then remove these two, and then we're done. And then let's do the last thing for users microservice. So 1, 2, 3 files that we won't need. And then let's resolve the imports. Let's see, where are they? Okay. There. So we just cleaned up all those scaffold files that were auto-generated when we create the project. So I'm going to go ahead and actually run Docker Compose right now, so we can see everything working. So, okay, perfect. So let's do Docker Compose up, -build. Hey, Critical Dev, long time no see. How are you? Okay, so we're going to run Docker Compose, and everything should build and, do its thing. Again, we're running this in development mode. Of course, if you wanted to run this in, production, you would need to make sure that you're not running the dev scripts. Sumit, how are you? Hopefully I did not butcher your name. I'm doing good, Critical Dev. Thank you. I'm just waiting for this Docker Compose to initialize our container and run it. So let me actually show you the Docker container now. I am using the GUI. So we just have to wait for it to finish running. Let's see. Cracking my knuckles while we wait. Okay, there we go. So all of our microservices were running. Okay, great. So now you can see that I have this container right over here, and it has all of our containers running over here. And you can see right over here that I have my root API. So I have my root API, and it says running on port 3000. So we know, one, our root API is running. Okay. And remember, once again, the root API is going to be our HTTP server that's going to listen to GET requests, POST requests, put, delete, patch, and it's also going to connect to the NATS server. I have my database up and running right over here. I can click on it, and if I go into, let's see, I'm going to go into exec. I'm going to log in to the database. And you can see I'm connected to my database that's running in a Docker container. So that's pretty cool. And then I also have the two other microservices running as well. I have payments microservice right here. I have users microservice right here. And let's see, I also have NATS server running right over here. And you can see it says right over here that starting NATS server, using configuration file, server's ready. So we're good. I'm watching your course about Nest. Can you make video about auth and make some easy projects about our knowledge? I actually do have a video in Nest.js, if that's what you mean, because some people confuse it with Next. But yes, I do have a video that uses authentication. It should be in my playlist. I'm pretty sure I did cover that. So definitely check that out. Okay. So my NATS server is now running. Okay, so to reiterate for those who are just joining in right now, let me pull up the diagram. So what we're building is we're architecting this system, right? We're gonna have an API that's going to receive HTTP requests. It's going to communicate with a NATS server, and a NATS server, you can kind of think of it like a way for you to work with distributed systems. It allows you to communicate with other systems in a very fast, low latency way. And I will be honest with you, I am still fairly new to understanding NATS as well. But if you're familiar with like messenger queues, it's kind of similar like that. Like if you've used Redis for pub sub type applications, it's kind of similar like that. But once we actually build everything out, it will make a lot more sense. So I currently have the NATS server running, and then I have the users and the payments microservice. And these two are currently running in the Docker container right over here. Okay. And we have a database. Okay. So now what we want to do is we want to let's see. Let's go into our root API and set up a controller. So I'm going to have let's see. We have two domains, users and payments. So I'll just create a new folder called users. Let me see. Let me do this real quick. Yes, I saw about easy projects, and the YouTube is very rare. Only if you buy one. It will be good if you make a playlist where you make easy projects. I hope you get what I mean. Yeah, I totally understand what you're talking about. Currently, I don't have any plans as of right now, but I am still kind of like brainstorming some ideas. Mainly because I want to actually do stuff like that, but also make sure it's not overly complicated. Whenever I do make a project for a tutorial, so I will take that into consideration because I know that a lot of people would definitely love that. Is this related to FAS or not because of the DB? Are you talking about functions as a service? Nest.js courses are expensive though. I will also mention, I'm not going to announce it now, but I'll announce it later. But I am currently working on a new thing for Nest.js, and I'll announce that later on throughout the next few weeks once I'm done working on it. Okay, so inside our root API, what we need to do is we need to set up two controllers. So one for users and one for payments. And actually, I'm sorry, let me rephrase that. We need to set up two modules, one for users and one for payments. And in each module, they'll have their respective controller. So I'll set up the users module first. So users.module.ts. And we're going to set up this module, which is going to just be a class. Okay, let me just import this. I also do have a new Nest.js video on Friday. It's going to be Nest.js with MongoDB. I didn't really announce it, but it is going to be Nest.js with MongoDB. So for those of you who are interested, the video is going to be live on Friday. So I hope some of you will like that. Okay, so we have our users module set up. I'm going to just copy this and do the same thing right now in the payments module. So I'm going to create a new folder called payments and then create a module called payments.module.ts. And I'm going to just rename this to payments module. And then I need to register these modules in the app.module.ts, which is our root module. So what we'll do is we'll import users module. Let me rename this to users module. Okay, users module and then payments module. And now I'm going to go ahead and create a new file. So we'll do payments first. I'll do payments.controller.ts. So we're going to use the controller decorator, which I don't know why my VS Code is messed up all the time with the imports, because I always have to restart the TS server. Then I'm going to import the controller decorator, and then I'm going to create a class called payments controller. Whoops, forgot to do this. And then I'm going to set the route to /payments. So that'll prefix all of our route handlers with the payments. Okay, so we'll do something easy. We'll do create payment and get payments. And maybe later we'll do get payments by ID. The goal of this live stream is not to do something complicated, but just to do something that's a proof of concept to show you all how this works. So I'm not gonna, so for that reason, I'm obviously not doing anything complex. And we'll also need a constructor to inject our services. Okay. All right. So I'm trying to think. Okay. So here's what's going to happen. The controller, so this is going to be a regular HTTP API request that we're going to receive in the root API. Okay. When we receive these requests, we want to communicate with our NATS server to be able to get the correct data from the correct microservice. So the payments microservice is where the data is going to be retrieved from, or it's the service that's going to take care of retrieving the payment data. Okay, so we need to configure the microservice module that's part of Nest.js in order to actually use it. So what I'm going to do first is this. I'm going to, inside my root Nest.js API, I need to install this package. So I'm going to open up a new terminal right inside over here. I'm going to cd into root Nest.js API. And I need to install at Nest.js / microservices. And I need to install NATS. And I need to do the same thing for the other two repositories, payments and users. So I'm going to do that very quickly. So I'm going to cd into payments microservice and install that. And I'm going to cd into users microservice and install the two same dependencies as well. I currently don't have a volume for my node modules folder, so I do need to restart my Docker container. Otherwise, it won't recognize those packages. Whoops. Okay. All right, so let's see. I'm gonna rebuild everything. Oh, I should have installed TypeORM as well because we are going to be interacting with the database. But it's fine. I'll redo it later. We'll do one thing at a time, so that way we don't do it like everything too much. That way you guys just get confused, and then it becomes hard to follow when you do so much all at once. Okay, so let's go back into the code while that is currently building. So what I need to do, well, actually, what I just said didn't really, actually, never mind. It does make sense. Okay, sorry about that. I was just kind of thinking out loud. Inside the root Nest.js API, let me actually zoom in a little bit so you all can see this. I apologize for that. So let me zoom in a little bit. Okay, so inside root Nest.js API, we need to configure let me open up the docs real quick. One sec. Hold on. Okay. Yeah, we need to configure, let me find the right, where is it? So we need to do this right over here. So we need to take the client module that comes from the microservice package that we just installed, and we need to register this with the NATS server so we can actually push messages to that NATS server. Okay, and like I said, I'm still new to this topic, so I do apologize ahead of time if I'm using the wrong terms, so do correct me. But let's go ahead and get the client's module, so you can see it's going to be imported from Nest.js / microservices, and then we just call this register method, and then all we need to do is just pass in this array, and then pass in this option over here. So it's going to look like this. So name, you can give it whatever you want. I'm just going to call this NATS service. I don't really know what other name to call it. And let's see, transport. So we need to set the transport to, let me import the enum up here. So we're going to set the transport to NATS, but you'll notice how Nest.js out of the box, well, not out of the box, but they do support a bunch of different types of transports. Like if you want to use gRPC, if you want to use Kafka, if you want to use MQTT, NATS, which is what we're doing, Redis, RMQ, or just regular TCP, you can do that. I'm going to select NATS. And then for the options, I just need to set the servers right over here, which is an array. And since we are using Docker, the host name is just going to be the name of our service name right over here, NATS. So I'm going to use the NATS protocol, and then the host name will be NATS, just like this. Of course, if you're not using Docker, which I highly recommend you use Docker, you would need to obviously use localhost or whatever server. Like let's say if you're running this on a cloud server, then you need to pass in that host name. And the default port is 4222. So I don't need to specify it like this. It will just use that default port. Okay. All right, so let's see. Okay, so we're done with this. So this will register for the NATS client. So then what we can do is we can inject the client anywhere we want, and then we can actually begin pushing messages to the NATS server. Okay. Now, I also did forget to do one more thing. I need to actually enable live reload. And I think this is actually a Windows specific problem, because right now, if I were to make changes and save, it's not going to actually update it in the Docker, because Docker, those files won't actually be updated in the Docker system. So what I can do is I can go into tsconfig.json file, and I can just copy, I can just paste these watch options, which I found off Stack Overflow that I have been using. So this will allow you to have the live reload working. Okay, so I'm going to paste that into every single project's tsconfig.json file. Mohammed, did I pronounce your name right? Hopefully, it has the C, so I don't know if I pronounced it correctly. So I apologize if I mispronounced it. But how are you? Welcome to the stream. So I'm just pasting all the watch options. So this is just for live reload. So whenever I make changes, it will actually update in Docker. Okay. And since I've already exited out of the application, I might as well install type ORM right now. So let me do that real quick. npm I Nest.js type ORM. So let me just install type ORM, and I forgot to install MySQL as well. So many things at once that we have to do. Let's just wait for that to finish. And don't worry, like I'm also gonna have a README in this repository, so that way you all can read it and try to understand what's going on. Because I know, following along the first time, it might be a little bit confusing, but the more you think about it, it just, it starts to make more sense. But let me just install the MySQL 2 driver. Okay, so I installed it from Payments Microservices, and now I need to go and do it for root. Well, actually, do we need to do it for root? Probably not. I'll do it for users microservice. So at Nest.js type ORM, and MySQL 2. All right, just making sure I got everything. Okay. So let's just let that do its thing. All right, cool. So we have all of our packages. I don't think there's anything more that we need to install now. So I'm going to go back into our root folder, and then I'm going to run docker compose up, and then build everything again. So while that's happening, we can continue developing our app. Okay, so where are we? So let's go back to the root API. So what we just did was we went into the app.module.ts and we registered the clients module. Okay, so now what I'm going to do is I'm going to go ahead and inject this client proxy instance into the payments controller. So it's going to look something like this. Let me show you the docs, so that way you all know where to go as well to find it. Should be somewhere over. I wonder why they always put this all over the place. Okay, yeah. So inject, and then the name of the service that we just gave it, and then private client proxy. So that's how we can inject that client to communicate with the NATS server. So at inject, and then the name of the service was called NATS_service in caps, and then private. I'm just going to call this NATS client, and then we're going to type annotate it with this, it's client proxy, and that comes from Nest.js microservices. So let me import that. Okay, so now Let me just check my Docker. Okay, so now you can see that I have the NATS client over here that's injected. So what I'll do is, just to show you how cool this is going to be, before I do anything else, before I do any saving to the database, all that kind of stuff, let me show you a very simple example. Because right now all we've done was a lot of setup, but I want to show you how this is going to work. So what I'm going to do is oh yeah, I need to use the get decorator. So I'm going to use this get decorator, and we're going to make a get request to /payments. Okay. And then it's going to go ahead and invoke this function or this method. And I'm going to go ahead and do return this.nats client. And there's actually two ways that you can communicate with the NAT server. You can use a request response, so that way you can actually wait for a response back and then send it back to the user. Or you can just do event-based, where you just publish events, and then all of the microservices can listen to those events and perform whatever business logic. Ziaruaman, how are you? Welcome to the stream. I'm gonna show you both examples. So I'm gonna do return this.nats client.send, and we need to specify a pattern. So I'm gonna show you the docs as well, because I want to have you all be able to know where to go to actually reference this stuff. So in case if there was something that I didn't do in the video, you guys can actually figure out where to go and see how to do this. So you can see right over here that this is the pattern. That's actually not a good example. Where's the .send method? Okay, right over here, perfect. So right over here, you can see that they have this method that's inside a controller, and then they have the pattern, which is just an object that has this command cmd property, and it's really just a string, and you can call it whatever you want. And then they have their payload, which is an array. And so what we want to do is we want to specify our command. So I'm going to go ahead and call this get payments. And I am going to use camel case because I prefer camel case. And I'm going to, I don't need to send any data, so I'll just do null. Okay. Lynn, how are you? Welcome back to the stream. Hope you're doing well. Okay, so here's what's going to happen. So now the NATS client is going to, I guess, I want to get the right definition. Okay, so what's going to happen is it's going to transmit this message based on this pattern to the remote microservice. And actually the return value of .send is an observable. You can see it says observable. So what we need to do in order to actually see how this works is we need to now go into the payments microservice, or really any microservice, and just listen to that event. But we're going to go into the payments microservice because we're working with payments right now. So we need to configure the microservice as well, because we haven't done anything yet in payments except for the payments microservice project, except for just installing packages and deleting some of the scaffold files. So inside the main.ts file in payments microservice project, right over here, payments microservice, we're going to go ahead and instead of doing nestfactory.create, we're going to do create microservice. And you can actually type annotate this to, let me check the docs again. There's this create microservice, or this microservice options that you can use to type. You can use to type annotate this method call. So you'll still pass in the app module, but then you want to pass in this options right over here. So we'll set the transport to transport. I need to import the enum as well. So transport dot, and you want to obviously specify the correct one that you're using. So we're using NATS. So we're going to select NATS. Of course, if you're using, like I said, if you're using RPC, gRPC, you would select gRPC. Okay, and then for NATS, we do need to also specify the server as well. So options, servers, servers. And it's going to be the same exact NATS server that we connected from the root API. So going back to root API, if you look over here, it's going to be the same exact server, same host name, port, everything that we have running on Docker. July Chris, long time no see. Yes, how are you? Ellie, how are you doing? Long time no see. I hope you're doing well. I hope everything has been going well for you. So we're going to pass in the same protocol. So NATS :/ and then the host name, because we're inside Docker, we're going to use the service name NATS as the host name. And the port by default is 4222. We don't have to specify that because that's the default port that's going to use. And we're done. And we don't need to do this part. It's actually going to be app.listen without a port, because remember, we're not actually running an HTTP API on these microservices. So just to reiterate, the payments microservice is going to not use an HTTP API to receive data. It's going to communicate via TCP, and it's going to receive those messages from the NATS server. Okay. So hopefully that makes sense. So if I were to, run this application right now, I wouldn't be able to make any HTTP requests at all. There's no port that we're listening to. So hopefully that part makes sense. Now I do need to do the same thing in the users microservice. So what I'm going to do is I'm going to just copy this whole file because it's going to be the exact same thing. Go into main.ts and just paste it. Okay. Adrian, how are you? Welcome back. Thank you. I hope you have been doing well as well. Thanks. Glad to see you back. Thank you. Yeah, I've been around. I'm just happy to be making YouTube videos again. So we're going to do the same thing for users microservice and payments microservice for the main.ts file. Okay. So now watch this. We're going to go back to the payments microservice project, and I'm going to create a new folder. I'm going to call this, let's see, payments. I guess we'll do the same thing. I'm going to just copy this payments module.ts file from the root project and then just paste this over here. I want to keep everything modular, and I want to keep everything in its own place. That's why I'm creating a folder and all this stuff, because I want to keep it organized. Okay, so what I'm going to do is I'm going to create a new file. I'm going to create a controller as well, but this time it's not going to be an HTTP request controller. It's actually going to be a microservice controller, and the microservice controller will use the correct transport to receive and send messages. So we're still going to use the controller decorator, but we're not going to specify, like a route for this controller. And if you actually hover over this, it actually also mentions that it talks about HTTP controller, which we're not using, but it also talks about a microservice controller, and it says responds to requests as well as events running over a variety of transports. So, for example, TCP, gRPC, NATS, Kafka, things like that. So let's call this payments controller. And now this is where it becomes extremely interesting. I'm going to create a method called getPayments inside the payments controller file, the payments controller class file that is inside the payments microservice project. So although right now it might look the same as in our roots project, but it's really not. Okay. These are two different files. Now, what we're going to do is, since we are using the request response approach to send and receive data, we need to use this message pattern decorator, and then we need to specify the pattern that we want to use to kind of like subscribe to events. So, for example, the pattern here is get payments. So I need to use this exact command or this exact pattern to listen to events for get payments. Okay. So what I can do next is this. I need to go back to the doc so I can reference this. I can watch her live all day. Well, thank you, Lynn. I appreciate that. I try to make it as interesting as possible with topics like this. So I can use this @payload decorator. So let's do that. So @payload, and that's going to be imported from Nest.js /microservices package. And I'm just going to set the data to any for now, but I want to show you what happens when I console log this. And I'm just going to return the data back. Okay. So let's see. Oh yeah, I also need to make sure I register the controller in our payments module file. Payments controller. Yeah, okay, there we go. And then now I need to go inside the app.module.ts file in our payments microservice project and import that payments module. So that way we register it. So that way the app knows about the module and all of its controllers and providers. Okay, so seems like everything is working. All of our containers are running fine. Okay, so let's try this out. The moment of truth. Okay, so let me explain before we do anything. Let me explain what's going to happen. I'm going to make a GET request to the root API, which is running on port 3000. This root API is going to handle that request, that GET request, by sending a command to the NATS server. So this.nats client.send, and then we're going to specify the command and send no data. On the microservice, remember, the microservice is connected to the NATS server as well. So it's going to route that message over to this microservice. The NATS server will route that message over to this microservice. Okay? And in order to be able to listen to those messages, listen to those events, we need to use this message pattern decorator when we use .send. I'll show you the other approach as well when we use event-based. Okay? So it's going to basically invoke this method, and then all we're going to do is log it and then return the data. So remember, these are two completely separate applications right now that are running, or I should say three. Root API, users microservice, and payments microservice. And you're now going to see how we can communicate with different applications using NATS. So I'm going to go into Postman. I'm going to create a new request, HTTP. And we're running on port 3000, so I'm going to do localhost port 3000 / payments. Let me actually do one more thing, just because I'm just used to doing it this way. I'm going to go into the root API, and I'm going to do, before I call app.listen, I'm going to call app.use global prefix, I think. Prefix. Oh, set global prefix API. Okay, there we go. It should restart. And let's try this out. Okay. What's going on? Did it not restart? Let's see. Oh, that's interesting. I wonder why it didn't restart. Did I? Hold on 1 second. Let me just double check something. Let's see. It should have restarted. I don't know why it didn't. That's very strange. Unless if I did this wrong. Hold on. Hold on. Yeah, that's pretty weird. I don't know why that's not working. I guess I just gotta restart Docker, I guess. Let me do that. Does Anton have a LinkedIn? Yes, I do. I don't really use LinkedIn that much though, I will be honest. But I do have one. Okay, I don't know why that was not auto restarting. That's kind of weird. Let me try this. Does it auto restart? Okay, now it auto restarts, but it should still recognize that endpoint, unless if I did it wrong. Did I register? Oh, okay, I'm silly. I forgot to register. Of course, it's not going to work. Actually, no. Oh, yeah, right over here. Yeah, inside the payments module.ts in the root API project, I forgot to register our payments controller. So I got to do that. Silly me. Okay, now it should work. Okay, so we didn't do anything wrong. I just forgot to import that. Okay, so now if I click send, what's going on over here? Let's see. Oh, whoops, wait. NATS service. I guess I need to. Oh wait, I need to register this before the module. That's why. Yeah, it's because it's registering the module and then it's registering this NAT service. No wonder. Okay, that's okay. Let me go back here and what is this? Which one? Microservices root API. Let me restart this real quick. There we go. It should work now. What's going on? Huh. Well, let me see. Well, I'm registering an app module, so I shouldn't need to register it in here, but I guess it wants me to. Well, that's kind of weird that it wants me to do that. I guess I will and see if that fixes it. But normally, since I registered an app.module.ts, I should be able to use it everywhere in my application. Your avatar looks so much different between GitHub and YouTube. Yeah, because that picture from GitHub was back in like 2016, and the picture in YouTube was I think 2022 last year. Welcome back, Critical Dev. How are you? So that's why it might look different. Okay, let's see if this works now. Okay, so it gives us an internal server error. That's okay. The invalid data or message pattern. So it is working. It is communicating, but I think we just have the wrong command. I think. Let's see what's going on here. Okay, so get payments. So we have the same command. Let me see. I guess I don't think I can pass null. That's client.send. Maybe I have to pass an object. Okay, there we go. I guess I can't pass null, but I have to pass an object. Okay, so it finally works. So let me just kind of explain what we just did. So I just sent an HTTP request to API/payments. So I clicked send, and then it's going to go ahead and call this get payments method. So this is the root API right now. The root API is going to communicate with the NATS server using this NATS client. So we're going to send this command with this data over here. Okay, our payments microservice is going to listen to those events that are happening, and then it's going to console log data and then return the data. So whatever we return here is going to return back to right over here, and then this is going to return to the client. So that is why right now you're seeing that it's returning an empty object, because we're not really sending anything. Okay, but what I want to show you is if I look at the logs right now, you see how right now it is logging. It's logging everything inside this microservices payments project right over here. So you can kind of see it right over here. It's logging it over here. Now let me just show you one more thing, because we are communicating between two different projects right now. So just to show you how powerful this is on top of what we just did, I'm going to go into the users microservice, and what I'll do is the same exact thing, but for users. So what I'll do is source, I'll create a users module inside the users microservice. And then let me just copy, so I don't have to redo all of this stuff again. So let me, inside the users module.ts file in users microservice, I will create a users controller as well. And then let me register this. Okay, and we do have this connection, so that's good. All right, so now in the users controller, just for demonstration to show you all, I'm going to subscribe to that same command. So I'm going to subscribe to the same event right over here. So command get payments, and then I'm just going to do this just to show you how this works. Okay. So we're going to do the same exact thing at payload, data any, and then return data. And I'll also console log it here as well. So now what's going to happen is this will send events to, it should send it to both the payments microservice and the users microservice now. So watch this. I'm just going to send message hello world. And now if I make a get request, if you look at the logs, it's going to send to, let's see, should have sent to the users microservice. Let me double check. Oh, that's right. I forgot to do this. Whoops. I forgot to register the module. Okay, let me just double check to make sure I have everything. Okay, now it should work. So let's click send. Okay, so now notice how now, whenever I make one API call to /payments, both the user's microservice as well as the payments microservice receives that event. Okay, so it's communicating with different applications. Now, just to kind of like do one more thing to go even further, just to kind of like just show you all what more you could do. Imagine we have, let's say, 10 different microservices that needs to receive these types of events. It can be really anything, okay? So what I'll do right now is I'm going to take each microservice, and I'm just going to kind of, and this is the nice thing about Docker is what you can do with Docker Compose is you can create multiple instances of the same application. So right over here, I copied payments microservice. I'm going to paste this, and I'm going to call this payments microservice 2. Okay. And then this will create a second version or a second instance of the payments microservice application. So it's going to be the same thing, but I'm doing it just to show you all how we can have literally unlimited amount of microservices receiving events from the NATS server. So I'll do that for users microservice, and I'll do the same thing for, I did it for payments. Let me do it for users microservice. So users microservice _2. So now we have a total of 4 microservices. So let's see what happens when we make a get request now. So let's rerun everything. And just let it do its thing. All right. Seems like everything is working just fine without any issues. Let me double check. Just give me 1 second. One second. All right. So sorry about that. Let me go back to Docker. Okay, so now you see that I have microservice 1 for payment, or payments microservice 1, payments microservice 2, users microservice 1, and users microservice 2. So we have 4 microservices running in our Docker container, and then we have 1 root API. Okay, so what I'm going to do now is let me go ahead and go back to Postman and click send. So now this should log 4 times, and you can see right over here in my terminal, you can see that it is logging once in every single microservice. So just pretend like those duplicate microservices that we just created, they're the same instance of our users and payments microservice. It's just running in its own process, but pretend like they are their own microservice that handles its own different thing. Okay? You have all 4 of these microservices receiving these events, and it can perform whatever business logic it needs to do. So obviously right now, this is just a very simple example of how you can transmit these messages to a bunch of different microservices. In a realistic use case, you're going to want to send events to specific microservices, and each microservice will need to subscribe to specific events. So I'll show you how to do that. But hopefully, all of this makes sense. Hopefully you can see the usefulness behind this. So let's go ahead and move on. Let me go back to my Docker Compose, and let me just remove this and this, because I just wanted to create those just to show you all how that worked. And let me just rerun Docker Compose. So what I'm going to do now is I'm going to set up a database connection in the payments microservice and user microservice. So now here's the thing though. Typically in microservices, you really should be using separate databases. So each microservice should have its own connection to a database. Okay. But just to keep things simple, what we'll do is we'll connect to one database for now. And then if we have some time, we can try to connect to different databases. So here's the diagram right now. So far we have the API connecting to the NATS server, and the NATS server is communicating with all of our microservices. Now we just need the database connection. So that's not going to be super difficult, because all we need to do is, let's see. We're going to go into payments microservice. Well, so we'll do with payments first. So we're going to go into source, app.module, and then I'm going to go ahead and import type or module for root. And then we're going to pass in the options that we need for configuring type ORM to connect to our database. So the type is going to be MySQL. That's going to be our driver. And then the host is going to be called the name of our service for MySQL. So it's MySQL_DB. So that's the name of the host. The port is running on 3307, because that's what I have our Docker SQL container running on. The username is going to be test user. Password is test user 123. The database name is going to be, let's see, I did have a database created, I think right over here. Nest.js_DB. Okay, so there we go. What else? Synchronize, set that to true. Entities will be an array, and I think that's all we need actually. Okay. Yeah, I think that's all we need. We have the host, username, password, database, synchronize, port. Okay, perfect. So let's see. Seems like it errored out, so maybe something was wrong. What's going on? Insecure configuration. Let's see. Something might be wrong with our configuration. Prisma ORM, please, haha. About to get ready for work. Enjoy the rest of your stream. All right, you have a good one, and I hope you have fun at work. Okay, let me see. Something's wrong with the database connection. Let me just double check that real quick. Let me check the database connection as well as the connection to our type ORM configuration. Give me 1 second. So host is fine, port is fine, password, username, synchronize, type. Okay, synchronize true. Okay, so everything here seems okay. But what's going on with the connection though? Let me double check the compose file. Let's see, we have the image, we have the port. Everything seems to be okay, so I wonder what is going on with... Oh, wait. Hold on. Yeah, I don't know what just happened. Let me reset everything. Let's see. That will fix it. Sometimes you do need to rebuild your Docker. Okay, hopefully that works. Our microservice is still down for some reason. Oh yeah, no, these two are, oh yeah, let me delete that. Because these two were the old ones that we no longer have. Okay, so let's see. It seems like the database connection was successful. Because if it wasn't, it would have thrown an error, so that's good. So now if I go into, let me click on this, and let me click on here. And let me just log into the database. Okay, so yeah, that Nest.js DB is still there. Show tables. So there's no tables right now currently, and that's okay. So let's go ahead and actually create an entity. So let's go over here, new folder. Let's call this entities. And I'll create one for payments. So payments or payment.ts. So we'll create a payment entity for type RRM. So we'll use the entity decorator. I'm going to import this up top from @nest.js /type RRM. And let me just set the name to be payments. And I don't know why it's complaining about that, because it should not be a problem. I might need to reinstall the package again. Let me see. Let me restart the TS server. Maybe that will fix it. No, okay, maybe I gotta actually reinstall the package. Let me do that real quick. All right, let's see. All right, cool. Let's go back here. Let's rerun that command again. I don't know why it's still complaining about it though. Does it not come from there? Let me. Yeah, it comes from type RM. Oh wait, my bad. I think it comes from type RM. Whoops. Okay, so let me set the primary generated column to be a UUID. And then I'll call this payment ID string. And then we'll just have basic fields like amount, number. We'll just keep it simple for now. Okay. And what we'll do next is we'll go inside payments module, and then we'll reference type ORM module, and then call for feature, pass in that payment entity in this array. So that way we actually register the payment entity, so we can actually use the repository in our service layer once we actually work on that. And then we do need to go into app.module.ts and import payment like this. Use a microservice to make API. Yes, that is what we are doing. Okay, so now we have a connection to a database within the payments microservice. So what we need to do is whenever we, well, first we need to create a payment. So I will need to create a method to handle creating payments. But this time, instead of using message pattern, instead of just using the request response approach, well, actually we still will use this, but I'm just going to show an example where we can use an event-based approach, because there are two different ways that you can handle these events. So I'll just show you real quick. So you can see right over here, you have event-based, not this one. Where is it? Okay. So yeah, you have event-based and you have request response. So with request response, it's pretty much like you are sending a request and then you are actually receiving a message back. So this is useful when you need to actually, when you depend on that response back from the server. So if you need the response, then you should go with the request response approach, which is what we're doing with the message pattern decorator. If you don't care about the response and you just want to just publish events, do some business logic, and that's it, then use the event-based approach. Okay, just for a simple example, I will use the event-based approach just to show you all how this works, and you can see the differences between either one. Okay, it really just depends. You can accomplish the same thing using both, but it's just really up to what you need. Okay, so inside our payments microservice project, in the payments microservice controller, I really should rename this to payments microservice controller. What I'm going to do is I'm going to use this event pattern, and the argument for this decorator is just going to be a string. That's just going to be the name of our event that we want to listen to. So I'll just call this create payment, on create payment. Have you tried Supabase with Next.js 14? I did try Supabase a while ago, not with Next, but I did try before. I didn't really get too far with it, but I have been thinking about playing around with it for a little bit. So we're going to create a method called create payment, and we need to specify an argument that's going to be an object that will have the data that we're going to receive from where we are sending it from where we're sending it from. So I'm going to create a new file. I'm going to create a folder called DTOs. I'm going to create a new file called createpayment.dto.ts. And I'm going to create a class called createPaymentDTO. And since we only have one field that we need to create this record, I'm just going to do that. Amount number. Okay. And I'm not going to worry about validation for now, but you could use class validator and class transformer to perform validation. But I'm just going to, let's see. Payload. And then we're going to call this create payments DTO and type annotate it with create payments DTO like this. So it's gonna start to look very similar to the controller service architecture that you use with traditional REST APIs in Nest.js. So I am going to create a service layer to handle all of the business logic. So new file payments.service.ts. And then I'm going to create a class called payments service. Injectable from Nest.js common. And then what I'm going to do is I'm going to do two things. One, I need to inject my payment repository, because that's going to allow me to actually interact with the payments table in our database. So I'm going to use this inject repository decorator that comes from @nestjs/typerm. And I'm just going to pass in the entity, so payment, just like that. And then private payments repository. And then type annotate this with repository, which is a generic type, so we can pass in payment as a value right over here. So now I can actually use the payments repository. And let me confirm there are no errors. Good. So I'm going to go ahead and create a method called create payment. The signature of this method will look exactly the same like the one in the microservice controller, except we're not going to use the payload decorator. So we're going to call this argument create payment DTO, create payment DTO like that. And all we need to do is just do this return. Let's see, this dot payment repository dot creates. Pass in the object create payment DTO, and then dot save. Or actually, oh wait, I forgot this is not the other ORM that I was using. Alive after a long time. Welcome back, Anton. Thank you, Supreme. I appreciate that. Yeah, and it has been a while. New payment. Yep. So return this dot payments repository dot save. So we're creating this payment object, and we're going to save it to the database. So we're just going to return this. So this will be returned back to the controller where we're going to call that method. But first, we need to inject that payment service that we just created. So we're going to use the constructor injection to do this. So private payments service. And of course, we need to also set this, we need to add this as a provider in the payments module because it's going to give us an error in the console saying that it cannot resolve this dependency. So payments service add as a provider. Okay. So that error should go away, and it does. And now what I'll do is this. I'll go ahead and just do return this dot payments service, call create payment, passing create payment DTO. And now, assuming we did everything correctly, this should create a record in the database for payment. And then it will return this. Now, I don't necessarily know what happens when we do event-based because I don't think they have an example here. But we will figure out. I think we might still be able to get the return value, I think. But I'll figure that out right now. Okay. So what we need to do is we need to go back to the root API. So this is the root API. This is our project that is going to take HTTP requests, and then it is going to forward those requests by routing those messages to the correct microservice using NATS. Okay, so it's a hybrid application. That's how Nest.js defines it in their docs. They call this a hybrid app where you have two different sources on where you are getting and sending data from. And in this case, we are getting data from microservices or through TCP NATS and also HTTP requests. So I am going to set up a post request, and then I'm going to call this method create payment. And remember, we're inside the root project right now. And unfortunately, since we don't have like a central repository for all of our types, like our DTOs, our entities, we do need to, for now, just kind of like recreate all of this, but it's okay. I'll just do that for now. But actually, I don't really need to because here's what I'll do. I'll just do body create payment DTO just to kind of like speed up the process for now, but you should definitely create a DTO for this and type annotated. And actually, when it comes to validation, you should do it in the controller layer. So this root API kind of acts like a gateway if you think about it. It kind of acts like a proxy, and then it can do the validation and then forward the request to another microservice, if that makes sense. Ellie, how are you? Welcome to the stream. I gotta be right back. Give me like a few seconds. I gotta use the bathroom. All right, sorry about that. I was BRB. Daniel, how are you? Welcome to the stream. Okay, so picking up from where we left off. So what we're gonna do inside our root Nest.js API payment controller is we're gonna go ahead and do this. So we need to send the message to the NATS server, and that will route it to the correct microservice that is listening to those events. So instead of using NATS client.send, we're gonna do emit. Send is for request response. Emit is for just emitting the events. Okay. So what I'll do is the event name is going to be on create payment, and then we're gonna send create payment detail like this. Let me see. Oh wait. Oh, what the heck? Oh, I had it up there the entire time. I didn't even realize. Okay. Let's see. Okay, so now, let's see. Okay, so let's test this out and see how this works. Let's make sure our app is running fine. Okay, I'm good, Okay, so let's make a post request to /API/payments. Let's send a response or a request body. And the only thing that we need is amount. Amounts. I'll just do 199 cents. So I click send. Okay, so you'll notice how now when I go ahead and return this.nats client.emit, it doesn't actually give you the data back, unlike the .send. Okay, but don't worry about that. So what should have happened now is we should have emitted this on create payment event, and then in the payments microservice, okay, in the payments microservice, it should have subscribed to this event and listened to it when it was received. So it should have received the event, and then it should have called this create payment method, which will save the record to the database. So if everything worked fine, we should have one record in the database. So let's actually see what happened. So what I'll do is, let me actually see if I can connect to that SQL database. Let me see. I'm not even gonna worry about that. Let me just go into the Docker shell for the SQL server, and then I'll do this on my SQL. Just user, and use Nest.js DB, and now watch the select asterisk from payments, and you see I have that single payment in the database. I am new. Do you have file upload video for Nest.js, or will you make? I don't think I do. I actually made a video like that a while ago, but I never uploaded it. But I don't have it anymore because I don't have the file anymore. But I do plan on making it though. It just would require me to use something like an S3 bucket, so we can actually save the file to the cloud, something like that. I was thinking about doing that, but I don't have it right now, unfortunately. But okay, so you can see that right now, it did in fact create that record successfully. So we know it is working. Okay, and why is this good? Well, here's the reason. Because now I can continue building my payments microservice project, completely separate from the users microservice project. Now, why is that a good thing? Well, typically, for stuff like this, for microservices, they're really used for projects that are just really big, and if you have a really big team. So, obviously, if you're building your own application by yourself without anyone else working with you, then you wouldn't really do something like this. Unless if you wanted to take care of, managing everything, you could. It would just be a lot of stuff to manage. So you're better off doing a monolith application, just running your API on one single app and calling it a day. But in larger teams, it becomes a lot more difficult to have, let's say, 50 people working on one single project all at once. So I'll give you some context. In a previous company that I worked for a few years ago, uh, we had a really large team. We had like about, I think maybe 50 engineers. 50 engineers on just one of our teams. Of course, there were like about like 10 to 20 other, I think maybe like even more engineering teams in our whole company. But just within, who I worked with, it was about 50 people. And we had like a bunch of different projects that each, team, each smaller team owned. And you don't want all 50 people just contributing to one single repository, because think about it, right? Like, you're going to have, let's say, 50 people working on code all at once, and then there's going to be a lot of overlap. You're going to end up running into a lot of merge conflicts that you'll have to resolve. And you're going to have to do a bunch of redeployments of the entire monolith application. And instead, what is actually more beneficial is, instead of having a monolith app, you separate it into smaller apps. So let me go back to this diagram over here. But the microservices are connected with the same DB, right? So here's the thing that I also mentioned earlier as well, is typically microservices should be connected to their own individual database. But in some cases, you can also use the same database if you need to, but they really should belong to their own database. That's the whole purpose of microservice. They are completely separate from every other microservice itself. And then there are techniques to communicate with other microservices as well, which I will show. But going back to this diagram, you can see that I have an HTTP API, okay, and I now have this NATS server. So just pretend this API is our proxy, our gateway, the entry point to the rest of the bigger infrastructure behind the scenes. So going back to what I was talking about with having 50 engineers working on one single repository, instead you now divide, let's say we have 5 microservices and 10 engineers work on one repository, 10 engineers work on the other. So you assign 10 people per project. Okay. That makes it a lot more simpler to manage, because instead of just having everyone just committing to one single repository, running pull requests, running the pipeline over and over again, you have 5 different projects. Each team owns a particular microservice, which is typically, how it goes down in companies. Each team will have ownership over a project. So let's say, for example, I own the user's microservice and I have a team of 5 engineers. So I lead this project and my 5 engineers will all work on this microservice project right over here. We can make changes to this repository and then deploy the app as many times as we want, and it will not affect the other microservice applications. So now what happens is you go from making one change in a monolith app, and then you have to redeploy everything again. And then you go from that to having to have everything separate. And then when you redeploy, you only redeploy the individual microservice instead of the entire monolith app itself. Hopefully that makes sense. How do you work on projects together, like 5 people in the same files? Well, I mean, if it's like a small, of course, let's say, for example, this really only applies to, like what I just said, just really mainly applies to large companies or large teams. But if let's say you're working on an open source project with like 4 of your friends, you don't really have to do something like this, okay? Because obviously it's a small team, you can communicate your changes effectively. You can say, hey, I'm going to do this, this, and that. I'm going to wait for you to finish this. I'm going to wait for this person to finish this before I start working on X, Y, and Z. So it's easier to communicate. Of course, when you have a large team, there's a lot of people that you're interacting with, and sometimes, you just can't really depend on one person to finish X, Y, and Z before you can work on this. And so that's where dividing the entire platform into microservices would make a lot of sense. Of course, you don't have to, but from what I've read on online, from what I've researched, a lot of companies do use microservices. Like there's no way that people can believe that something like Facebook or Instagram has everything running on one single API. Like, of course they have something like a gateway. They have a bunch of different microservices that are connected from each other, things like that. So you wait someone else to push that changes before yours. No, not necessarily. Like, what I'm saying is, when you work on a smaller team, it becomes it is easier for you to communicate, what you're about to do. So sometimes merge conflicts are extremely extremely painful to deal with. So instead of, having to deal with that, what you might do is you might say, hey, if that change is really small, let's say you're just making a one line change or a few line changes. I'll just say, once you're done, I'll begin working on that. And now, if of course that's not ideal, you want to be able to work in synchronous. So you do need to deal with merge conflicts if there are any, that is. But when you're working with a large team, let's say if you have 20 or more people working on one single repository, you're definitely going to have a hard time keeping up to date with the remote upstream. Because let's say there's a whole bunch of tickets that are divided amongst all the engineers, and you're working on one ticket. And let's say your ticket is so big that it's going to take a while for you to finish. Let's say it'll take you a day to finish, whereas it will take the rest of the other engineers to finish their ticket in, like, let's say 2 hours. They are going to finish their ticket way before you. And when you are done with your work, you now have 20 commits. You're now 20 commits behind the main branch. So you have to pull down all of those commits on the remote main branch. And then you have to do some rebasing, and you have to just pray that there are no merge conflicts, because if there are, then you have to fix that, And then it can become more problematic too when their changes conflict with your changes. And for example, like, they might do something that deletes an entire API call, whereas you needed that API call to do something. So that's what I'm trying to get at when you're working on one project with a bunch of other people. But like I said, it really mainly applies to a larger application with a lot of people working together, to build the entire bigger product. If it's just a small product, not too many people working on it, then you don't really need microservices. Okay? Because you also have to understand that when you deploy all of these applications, it will also take up CPU usage, it'll also take up memory. So you also have to account for that as well. So hopefully that makes sense. Okay? But now, going back to our code, I do want to finish this out. But of course, if you have any other questions, feel free to let me know in the chat. But now we are able to create payments in the payments microservice. Let's do one for users microservice now. Okay? So I'll show you one example where we are connecting to the same database. What I'll do is I'll go into my payments microservice, and I'll just copy this exact configuration for payments microservice, because it's really just going to be the same thing. We're going to connect to the same database right now. And then, let me go over here. Let me import this. Okay, so we're going to connect to, and we also need a new entity as well. So let me do that. So inside the user microservice, I'll create a source, or not source, I'll create a new folder called entities. And then user.ts, I'll create a user entity. Okay. Entity. And then let me import that from type-orm. Okay, so I'll keep this very simple. So I'll do primary generated column ID string, because I want to use a UUID. So this will auto-generate the ID when we create the user. We'll just do a simple example. So we'll do username string. What else? Display name string, column, email string. An entity is specific to type-orm, but it basically is just a class that type-orm will map over to a database in the form of a table. So for example, this is really just a class, right? This @entity decorator just tells type-orm that this is going to be what we want to translate from a class into an actual SQL table, or whatever database you're using. In this case, I'm using MySQL, so it's going to create this user class as a table in MySQL. Hopefully that makes sense. I'm more than happy to clarify as well. Okay, so I just created this user entity, so we are good to go with this. And I'm going to go ahead and import this into the user entities array right over here, or the entities array. And then what I'll do is, let's see, we do need to register the repository. So inside the users module .ts file, I am going to need to call for feature, and this registers the user entity, so that way we can actually use the repository. I do need to import type ORM module though. Type ORM. Why type ORM and not Prisma? Nothing against Prisma. I just prefer to use type ORM. I have actually tried using Prisma in the past, but I don't know. You know, I'm not actually. I don't really like. I didn't really like it that much because of the way that things were done differently. Actually, you know, I'll tell you exactly why I didn't really like it. I'll show you right now. So, in Prisma, they use a schema first approach. I don't know if you can actually use class code first approach. If you can, let me know, because I'd be more than happy to explore that. But from what I've seen, it seems like it's mainly just schema first approach. And what I mean by that is, you can see right over here that you define a Prisma schema, and then you have to do this migrate stuff, and then you have to also generate the actual. I used it when I was using Next.js, and then you have to generate the actual like types, I think. So it's been a while. I think it's the last time I used it was 1 year ago. So I don't know if some things have changed, but I don't know. I didn't really like it that much. I kind of liked using it. I kind of like using type ORM because it allows me to do code first approach, where I can create a class and then use decorators to tell type ORM to translate this into an actual database table. So I've just kind of stuck with it since then. But that's just my preference though. Nothing against Prisma at all. Okay, so let's see. Let's create the user service. Injectable. So inside the user service class, we will need to inject the repository that we're going to use, which is the user repository. So I'll do that right over here. So private, oh, whoops, it's inject repository, user, private repository, users repository. And type annotate this with the repository type, like this. I don't know why my imports are messed up. It is kind of annoying sometimes, and I have to restart my what's it called? TypeScript server all the time. From type ORM. Okay. Okay, so let me go ahead and add the user service as a provider in our users module. And then, let's see. Okay, user module is already registered. Cool. So what I'm going to do now is I'm going to create a method called create user. And it's just going to be the same thing that I did with payments, where we have our create user DTO. We're going to make a post request to the root API. The root API is going to transmit the message over to the user's microservice. And then the user's microservice is going to create the actual user in a database. Hello, what is NATS? Welcome to the stream, Seth. Well, NATS is used. NATS is pretty much like, there's a lot of things that NATS is. So it's hard to kind of like describe it all in one sentence, but mainly like you can use it for, you know, handling real-time data. You can use it for pub sub type applications, like publish subscribe type applications. You can use it as like a message queue if you want to, but mainly like you can use it to transport messages to different applications. In our case, we're using NATS to communicate with multiple different microservices. Hopefully that makes sense. How do you guys find freelance work? Nothing works for me. Fiverr is a good one. Paulo, hello from Brazil. Welcome, Paulo, to the stream. How are you? Hello, I'm FE Dev with almost 2 years experience. I want to learn backend. I use the bit Next.js, but what are you doing here is black magic for me. Could you help me? How should I start? Well, if you've used Next.js, and if you're used to Next.js, what I would recommend you do is try using Express first. I'm using Nest.js, not Next, Nest.js, completely different tool. But learn Express because it's going to be very easy for you since you've already used Next.js. A lot of the references will be very, very similar. So I think you'll have a lot of good experience with that. And I do have a video playlist on my channel that that I think would help you out a lot. So I'd highly recommend you learn Express.js. And then once you get used to Express, maybe you can look into Nest because I think Nest.js is a very, very amazing tool. Okay. All right. So let's just quickly go back to this. So what I'm going to do inside here, inside the users microservice project, is I'm going to create user DTO. So let me create a folder called DTO. And I'll call this create user.dto.ts. It's just going to be a class. Create user DTO. It's going to have a username. It's going to have a display name and an email field. Okay. I'm going to copy this and I'm going to go ahead and the signature of this method, I'm going to pass in one argument called create user DTO. Type annotate it with the create user DTO class that I just created. And then all we're going to do is just create this record in the database by passing this create user DTO into this method. So const new user equals this dot user repository dot create. Pass in create user DTO. So this will create the user instance, and then we just need to save it to the database. So I'll do return this dot user repository dot save new user. So this will actually save the record to the database. So we're done with our user service for now. I'm going to go back into, let's see, right over here. Okay. Oh, wait, whoops. Oh, that's right. I got to modify this. I had this earlier to show an example, just to show you how we can send messages to different microservices. But what I'll do now is I'm going to change this from get payments to create user. And I'm going to change this method to create user. And then I'm going to rename this the user's microservice controller just because it is technically a different type of controller, not a regular HTTP controller. Okay. And so what I'll do is inside the microservice controller, I'm going to go ahead and inject that user service that I just created. So private user service, users service. Let me just make sure it is registered. Yes, it is. So we're good. And then all we're going to do is simply this. I'm going to type annotate this data to create user DTO. And might as well because we already have it already. And then I'm going to do this. I'm going to return this user service create user, pass some data. Hello, very happy to see you come back. Have you used RabbitMQ for microservice? I have not yet, but you know what? I'm willing to try it out because I've actually used it one time before, but not with Docker, and it was actually hard to set up because I was not using Docker, but I am going to give it a shot maybe sometime. Do you pronounce your name Dehua? Did I pronounce your name correctly? Or maybe actually I think sorry, I was reading your name in a different language. I apologize. But yeah, tell me how to pronounce your name because that seems like a really interesting name. I thought it was Russian for some reason. Richard, glad to see you back, Anson. Well, welcome back to the stream, Richard. I hope you're doing well. Okay, so let me recap what I just did. So what I just did was I created this message pattern, which is going to handle the create user events whenever we publish them to the NATS server. We're going to receive this event, and then it's going to go ahead and call this method, and then it's going to go ahead and call the users service.createUser method to actually create the user in the database. That's all it does. So now to actually have this event receive this event inside this user's microservice controller, we need to go back into the root project, the root Nest.js API, and actually send that event over. So that way the user's microservice can receive it. If I remember right, you know Russian a little bit. I haven't been practicing it much, but I do know a little bit. Not so great now, but I did practice it for a little bit. Okay, so back in the root project, what we need to do is, so remember how earlier I created this users module.ts file inside the root API? So we're going to actually create a controller, and this is going to be an HTTP controller, not a microservice controller. Completely different thing. The HTTP controller is going to handle HTTP requests. The microservice controller handles non-HTTP requests, but it still handles TCP as the transport. It uses TCP as a transport to handle messages being routed to the correct microservice. So let's go ahead and set up the controller. Let me do this. I don't know why my TypeScript is so messed up, or my VS Code is so messed up. But let me just import that. Okay, so the route for this will be users. And then the class name will be users controller. We're not going to need a service class for this, for this project, for this root Nest.js API project. We're going to go ahead and do this. We do need to inject this NATS service that we did inside payments controller. So let's go ahead and do that. Constructor. So let's inject this client proxy instance in here. And then let's import client proxy from Nest.js microservices. Let's see if we get any issues. No issues so far, so that's good. Okay, let's register that user's controller. We might get an error though. Let's see. Yeah, it's complaining about this NAT service. I still wonder why. You know what I'm going to do? Because I don't want to keep on importing this in every single module. So let me do this. NATS clients. Let me create a... Let me do this NATS client.module.ts. Let me create another module that just exports this. Okay. And then what I'll do is, let me rename this as well. NATS client module. And then what I'll do is I'll import NATS client module everywhere. So that way I don't have to import this thing. So hopefully that should work, because I don't want to have to keep on copying and pasting this everywhere that I need it. So let's try that, and hopefully that error should go away. Let's see. Oh, maybe I need to do this. Maybe I need to import it and then export it. Okay, seems like that worked. So I hope we don't run into any issues with that. Okay. Yeah, I don't know. Hopefully we don't run into any issues with that. So now I can just import NATS client module everywhere, so I don't have to copy and paste everything over and over again. So let's try importing it here in payments. Okay, no errors. That's good. No dependency errors. Okay, so going back to the users module in our root API. So now that we have this NATS client injected, we're going to go ahead and set up a route. So let's do post. Let me import that decorator. So this is for creating a user, of course. So create user. We are going to need the DTO. I'm just going to copy that. Yeah, because I didn't do that same thing for payments microservice. So let me just copy this real quick. DTO. Create user DTO. Okay. And the reason why I'm doing this is because I am going to put this code on GitHub for all of you to use as a reference. So I want to make it as organized and neat and as informative as possible. So that way you all have something in good hands to build on top of if you decide to use this for whatever reason. Or just follow along as a reference. Okay, so I have create user DTO, and then I'm going to do app body, which is going to be imported from Nest.js common. And then create user DTO will be the name of our argument in the method. And we'll type annotate it with create user DTO that we just created right over here. And then we can just simply return this .nats client.send. And then the pattern is going to be, remember, that pattern is going to be this create user pattern. It has to match. So create user. And we're going to pass the data like this. Okay. So what will happen now is we're going to go into Postman. We're going to make a post request to localhost port 3000 because that's what our API is running on. API/users. So that's going to target this create user method when we make a post request. We're going to send a request body with the username, display name, and email. And then what we're going to do is we're just going to send the data over to the correct microservice, which is the user's microservice right over here. So the user microservice will handle this create user event, and it's going to create the user in the database and then return the record that was created. So if we did everything correctly, everything should work fine. So let's test it out. So what I'll do is I'm inside my MySQL shell in Docker. Okay, so now I have two tables because I am using the synchronize field set to true. So every single time I set up a new entity, it's going to go ahead and create that entity as a table in our database. But you'll see right now, if I select from the users table, you see it's an empty set. Okay, but watch what happens when I go into Postman and do this. So I'm going to go and create a new request. Oops. Users. Send JSON. So we need username, Anson, display name, Anson the dev. Lyrosphere, how are you? I just saw your message. So I'm looking at my YouTube chat because it's closer. Because the YouTube chat on my left monitor is closer to my center monitor, so I can really easily glance over it. But when I look at my right monitor, which has my Streamlabs open, it seems like that chat updates faster, I think. So I apologize for just seeing the message just now, but I hope you're doing well. A long time no see. So let me set the display name and then email. I'll just do some random one, anson@ansonthedev.com. All right, so we're going to go ahead and click on send. And look at what just happened. So I know right now from the service level, it looks like a regular API call, but what happens underneath the hood is very, very interesting. So let's take another dive into what is going on. So I am sending a post request to my API running on port 3000. That API is our root API. Okay, think of it like a gateway that will take care of handling each request and forwarding the request to a microservice. So what happens is I receive that API call via this user's controller, okay? And then the controller, all it does is it uses the NATS client to send this event, okay? And then in our user's microservice, which is its own process, it is subscribing to this event right over here, this create user event. Okay, so once it receives this event, it's going to go ahead and create the user right over here. It's going to return it back to where it was called, and then it's going to, which was the root API right over here. Yeah, right over here, and then it's going to return it back to the client that made the call, which is right over here, and that's why we can see our user created in the database. Hopefully that makes sense, and if there's any confusion, feel free to let me know. I'm more than happy to clarify. Will you continue doing daily live stream? No promises on that. I don't know if I'll do daily, but I do want to live stream some more. I do want to do some more live streaming and making some more videos. In case of you all don't know, I do have a new video coming out this Friday for Nest.js. It's going to be Nest.js and MongoDB. So if you guys are looking for a video in particular to Nest.js and MongoDB, then that'll be the video for you. I heard that Postman provided features to test our route by sending 100 even more requests at a time. Is it true? I think so. I think you can do that in probably like a pre-request script. I'm not sure. I've never done it before. But it sounds like something that you could do in Postman. I'm not too sure though. But hopefully that makes sense, guys. Hopefully what I'm doing here is making sense. And if it doesn't, please let me know in the chat. I'm more than happy to clarify. So I have a question like this. What make it different when we call root API rather than call directly to the port where the user service in? So here's the thing. That's a good question. Okay. So your question needs to be answered in two different ways. So right now, we're actually not running the microservices on a port, okay? It's actually communicating via TCP to the NAT server. We're not running the microservice on a port. You see, like this controller that you see right over here, it's not taking any API calls. It's not taking any HTTP requests at all. The messages are being received via NATS. Okay, the NAT server is transporting those messages over to the microservice. The microservice is listening to those events. So it's not listening it to through HTTP. So I just wanted to clarify that because you're not wrong with what you just said. But here's the thing though, in some cases, because this is how Nest defines a microservice. Let me go back to the documentation. So this is kind of the reason why we have to do it like this. Okay, it's not the ideal way that I would do it personally, but it is actually a good way to do it because I've never done it like this before. I've always used HTTP APIs and I use like an HTTP client to forward the request. But I'll show you on the docs right over here. So you see how over here it says in Nest, a microservice is fundamentally an application that uses a different transport layer than HTTP. So the way that they designed it, and someone here can correct me if I'm wrong, but the way that I interpret this is they created these microservices in a way for you to use everything other than HTTP. Okay, so you can communicate using Redis, NATS, RabbitMQ, Kafka, gRPC, which I think gRPC is something nice to look into. So if you were doing it this way, then you wouldn't be able to actually call those HTTP APIs. Now, here's the thing, though. If you do need these microservices to receive HTTP requests, you can actually do that because in the documentation right over here, it talks about a hybrid application. And it's pretty much where you have an app that listens for requests from 2 or more different sources. So I'll give you an example. Our root API is a hybrid app because we are listening to requests via HTTP, but we can also listen to requests via NATS as well. But we didn't set it up that way because we only really need. Well, this is what it does, right? This is what it does. Not here, sorry, right over here. So right over here, we are listening to port 3000. But if we wanted to have have a hybrid app where the root API can receive messages from the NAT server, all I have to do is just change what I have right over here, and just pretty much call connect microservice, pass in the transport, specify the server, and then there we go. So that's a great question. That's a great question because there's no right or wrong answer because you can have a microservice primarily use HTTP and HTTP only, or you can have microservices use gRPC. You can have microservices use RabbitMQ. It's really up to you. Yeah, it's just really up to you. But identifying these different approaches is what makes a good software architect, figure out what's more effective. For example, some people might find using NATS is a lot more faster and more efficient than using HTTP. And there might be some features that NATS provide that maybe using HTTP might not. Because I'll give you another example too, right? Let's say if you were to use HTTP only, you would need to make an HTTP request to every single microservice in order for those microservices to receive those events. If you use something like NATS, all you have to do is just go to every single microservice and just subscribe to the event, and that's it. You don't have to worry about making additional API calls, which can slow down your application. So hopefully that makes sense. That's like one thing that I can think about. Is NATS more secure than HTTPS? Well, I think with NATS, you can actually encrypt. There should be somewhere in the docs where it talks about encryption. It should be somewhere over here, I think. I'm not too sure. Security. Yeah, you can encrypt it with TLS. Hopefully that, so you can, if you have like a certificate and a key, you can use that to encrypt everything, so that way it's actually secure instead of just making it non-encrypted, which is what you don't want. Hopefully that answers that question. Okay, so let me continue on with everything else. Okay, so now let me give you an example, right? Let's say right now, I just created a user, but what if I had another microservice? Okay, what if I had another microservice that needed to know when a user was created? So you know what? Let me do one more example. So just a simple example, right? What if I had one? What if I wanted to do something whenever I created a user? I wanted to notify other microservices that a user was created. How would I do that? Well, there's two ways. One, you can either have the user's microservice communicate with all the other microservices, or you can send that response back and then have the API controller, send another event. So I'll kind of explain what I'm talking about. So let me go back here. Okay, so we're gonna go back to the user's microservice project. Where is it? Okay, so we're gonna create a user. We're gonna return this return value back. So that's gonna go back to the root API where we sent the event with the payload. I'm gonna inside over here, inside root Nest.js API. Right over here. So this is where I'm gonna get the data back. From here, I can go ahead and actually get the return value, and then I can emit another event to all the other microservices to say, hey, a user was created. So to do this, we do need to do a couple things, because this return value, this .send, actually returns an observable. You can see if I hover over send, the return value is an observable. Okay, so before you could actually use toPromise method to get the actual value, but it's deprecated now. So the alternative is to use this RxJS operator called last value from. Let me see. Let me show you. Yeah, you just use last value from, which is pretty much the equivalent to toPromise. Converts an observable to a promise by subscribing to the observable, waiting for it to complete, and resolving the return promise with the last value from the observed stream. In this case, it's only going to be one value from, I guess, from the observed stream. So, yeah, RxJS should also be... RxJS is already installed, so I can just import it right up here. Last value from. So now all I can do is just do const new user equals awaits, and then just take this whole call, last value from, pass it in here like that, and then let me add async here, and let me return new user. Hopefully everything works fine. Let's see. Okay, there we go. So it is still working fine. And just to also note that Nest.js takes care of handling the observable for you underneath the hood. So that's why you don't need to do all of this. But if you do need the actual value, then you would need to use last value from to actually get the value. But with this, what I can do now is I can just simply do this .NATS client and I don't care about getting a response back because I just want to emit the event. So I can just do .emit, and I can just say on user created, send the new user, and yeah, I think that's it. I think we don't need to worry about doing anything else from that. I hope this doesn't block this return though. Let me double check. Let me try Jack, and then Jack. Okay, there we go. So it doesn't block that return, so that's good. Okay, so now what I'm going to do is I'm going to go into the payments microservice, okay? And I'm going to show you how the payments microservice can know about what's going on in the user's microservice. So I'm emitting this on user created event, and pretty much any microservice that's subscribing to the NAT server that subscribes to this specific event can receive it. So if I go back to, I'll just use this payments controller as an example. Okay. So I'm going to go ahead and do event pattern. The name of the event, so on user created. And then we're just going to do handle on user created. And then the payload is just going to be a user. And of course, you would need to make sure that you have an actual user type. But in my case, I don't. So I'll just set this to any just for now. And I'll just console log the user. And I want you to take a look at the logs and see what happens. Don't know why, but the NATS client emits somehow has like socket gateway. It kind of is. It's a way for you to perform real time, data updates. Okay, so it kind of is in a way. But so here's what we're gonna do. We're gonna go ahead and create a user now. The user is gonna go ahead and be saved to the database. We're going to see the response returned right down over here. And then what's gonna happen is in the logs, you're gonna see from the payments microservice process, it's going to go ahead and log the user created. So the point here is to observe that the other microservice running in its own process that is completely isolated from all of our other apps that are running is receiving updates from for whenever a user is created. So what I'm going to do is I'll create a new user. I'll do Jake. Let's do display name Jake and email Jake. So watch this. Currently there's nothing in the logs. Click send. So I created the user Jake, and if you look at the logs right now, notice how Nest.js microservice payments, so this is the payments microservice, is logging the user. So now the payments microservice knows what's going on whenever we create a user. So it went from not knowing, being in its own isolated environment, its own individual process, to now being able to perform business logic whenever a user is created. And you're probably wondering, well, why is this useful? Well, not in this particular case, because I'm just showing you this as an example, but I'll give you a realistic use case. Let's say you have a user's microservice. So let me go back to my Figma diagram. So let's say you have a user's microservice, and let's say you have another microservice. Okay, let's say you have author's microservice. Let's say you're building a blogging platform. Okay, so the author is of course going to be relevant with the user because maybe you want the user to be representing the actual user on the platform, and then you want to have the author record represent an actual author of a post. So users can be authors and authors can be users, or I think actually it's users can be authors, but authors, I guess because there is going to be a one-to-one relationship in the end anyways. But let's just use this example. Let's say when I create a user, I want to also create an author record as well that has a one-to-one relationship with that user. Okay, because for example, the author record might have a bunch of fields that pertains to the author and it shouldn't belong to the user. So you're encapsulating a bunch of fields and data that is relevant to the author, and it's not necessarily immediately relevant to the user record. So for example, an author will have, let's say, posts, it'll have comments, it'll have what are other fields that an author can have? It could have last post date, things like that. Now, you could technically put that in the user record, but again, the whole purpose of this is to aggregate your data, is to encapsulate your data in its corresponding domain, okay? But if you have an author's microservice, you can't just create that author record inside the user's microservice. You need to create the user in the user's microservice, and then you need to communicate with the author's microservice, either the way that we just did right now, where we return the value back to the root API and had the root API emit this event, and then in the corresponding microservice that needs that event, subscribe to it, and then perform that record. So hopefully, I hope that makes sense, and if it doesn't, let me know. Okay. So yeah, that is pretty much most of what I have for this whole thing. And the reason why I wanted to do this live is because that way I can actually go through all of this, because I'm still learning about this stuff too, and I'm sure I've got some of the terminology messed up a little bit, so I got to do some research and fine tune my understanding of this. But this is just kind of like a most basic implementation of one way out of many possibilities you can do with microservices. But yeah, I just wanted to share this with you all because I think that this is super cool. And now you can literally have a really big project and have multiple people work on it, and not even have to worry about them overriding your changes. So if I were to push this to GitHub right now, um, I can have 3 separate repositories. I can focus mainly on the root API. My friend can focus on the user's microservice project. And then someone else from, like, I don't know, Australia can focus on the payments microservice project. So it allows you to, work on things independently, increases productivity, makes it easier to test. Also, I forgot to mention that as well. It makes it easier for you to perform tests, which is another important thing. So I hope that makes sense. So the last thing that I do want to do before I sign off is I do want to try to configure different databases with each microservice, because I think that would, because then that's what it really is. That's where it really is a true microservice, where it has its own database. So let's see. I think what we can do is we can just change the name of the database. But I do need to do this though. Docker compose. Let me see something real quick, because in the Docker compose file, this MySQL database creates the database for us. So I need to see how I can create multiple. So I need to actually check. Let's see. There should be a way to do that though. MySQL Docker. Does each microservice really need its own database? Well, it is up for debate. Like I said, it really depends on your use case. Microservice database. Because, for example, some articles will say your microservices can share database. Some say it'll have its own. So I'll show you the Stack Overflow post that talks about it. So over here it says you can use a single shared database with tables that are owned by different microservices if your data is heavily related. Also, in case you have strong requirements on data consistency and availability of a service, there is pros and cons. So what they're saying is that if you have a lot of relational data, then you should definitely share a database, because it makes it easier, because obviously you can actually perform joins and query data a lot easier all in one SQL query. If you're using something like MongoDB or something that is like a NoSQL database with no relational data whatsoever, then yeah, you can actually just use different databases. So let me answer these 2 questions, and then I'll get back to that. Crayhost, how are you? Welcome to the stream. Is NATS related to sockets, subscribing and embedded events? And yes, it is related in some ways. On how you do certain things is related somewhat. But so I'll give you an example. If you have an application that has no relational data at all whatsoever, then yes, you can use separate databases for each microservice. And so, for example, if you don't need to worry about having to query 3 different tables and do a bunch of joins to get the correct data for the user, then you don't have to even worry about that at all. Okay, you can have individual databases for each. So there are pros and cons. So for example, reliability, you can have total consistent incremental backup of the entire system without downtime with standard DB tools. In case of an event-driven architecture, you can store your events with data, fully constrained. There's less maintenance as well. But it does seem like there are a lot of cons over pros. I will say that from what I'm seeing over here. Okay. Hype, yo, how are you, man? And thank you so much for the 10 pounds. I really appreciate that. Thank you so much, man. I hope you're doing well. Yeah, it has been a while. It has been a while. I haven't really been on Discord much, actually. I haven't even checked Discord for like the past 3 to 4 months. But I hope you're doing well, and I hope everything has been going well for you with school and your career with being a developer. Do you play some games in your free time? Sometimes I do. The last game that I played was City Skylines. That's actually the only game that I play anymore, because I used to play Overwatch. I used to play League of Legends. I don't really play Overwatch at all, because Overwatch 2 I don't really like it. And I sometimes will play League, but I haven't played it for like the past 3 months. But I do play City Skylines. I think it's a great game that teaches you a lot about city planning and urban planning, and I think it teaches you a lot about real life stuff. So yeah, I like that game a lot. All good, all good. How about you? I'm doing good, hype. Thank you. And yeah, it's nice to see you here. Um, how are you, man? Long time. Yeah, I've been good, man. And I do recognize a lot of you guys. Like a lot of people I recognize from a year ago. Jishu, you're one of the people that I recognize. So yeah, there's a lot of familiar faces here and a lot of new faces too. Have you seen the GTA 6 trailer? Yeah, actually I did. And it's actually crazy how within like 24 hours they had like what 95 million views, which I think that's like the most viewed video in 24 hours. I think now. I think I'm not sure, but yeah, I'm looking forward to GTA 6 for sure. It's coming out in 2025, so by then probably I'll have a better GPU. I'm currently running a 3060, so I'm hoping to get a 4080 or 4090 by then. So I'm gonna work on saving up for that. But back to what we were talking about. So let's see. Yeah, so there are a lot of pros and cons with having different databases, but I guess it wouldn't really make much sense if you're using SQL because you have a lot of relational data. So why would you want to separate that? It wouldn't really make much sense. But if you needed separate databases, then what I would do is I would pretty much just um, create a entire new database. I don't know. I wonder how I can create different database names though, because there's this. Let me look this up real quick because I really want to see if I can actually do this because that would actually be pretty cool. Because there's this flag down over here or this environment variable that it tells you right over here. This variable is optional and allows you to specify the name of a database to be created on image startup if a user password is supplied. But it doesn't say anything about multiple databases. So I wonder if I can like pass an array. I don't know. Let me see. Docker. Let me Google this. Supreme. Yeah, of course I remember you. I remember you were in my live stream whenever I was building the chat application last year. You were there all the time. I think you said you were from the UK, right? Is that right? I think I do remember you were from the UK. The theme is Horizon. I think my theme is Horizon theme. Let me. Yeah, I'm using Horizon for those who are wondering. Horizon theme. Switzerland. Oh yeah, that's right. My bad. Yeah, Switzerland. That's right. Oh, I completely failed that. Let's see. Okay, what was this called? Uh, okay, so Docker compose multiple. I want to create multiple databases on startup. If I can't do this, then I might need to just run a script. I guess I don't know. I might need to run a script if I can't do this. But it does say instead of creating databases in Docker compose file, just create them in SQL files. But I might as well just get it done in Docker if it's gonna do that. I'll have to use multiple datas. Oh, you know what? Oh wait, actually, I think I figured it out. So it says on Stack Overflow that I can create a SQL file and attach as a volume, and then it will run that SQL file as an image entry point script. So let me try that. Init.sql, I guess. Create database if not exists. So I'll just do this Nest.js DB. And I'll do one for users. And then Nest.js payments. And then I need to go into compose and let's see, set the volume. So ./init.sql. And then now where do I put this? That's the question. Where do I want to mount this? Oh, okay. It's Docker entry point init db.d and then init.sq. I think this is from what I'm seeing here. I hope this works. A guy on internet, shout out my name, please. Way ahead of you, my friend. Trying to fool me? No. I know what that says. Can't fool me. I've been on the internet for a very long time, so I know all of those tricks. I guess I have to keep my guard up then. Okay, so let's see. I hope this worked. Look at my container. Doesn't seem like there's any issues. Let's go to exec. Okay. Test user 123. Did it work? No, it didn't. Volumes init Docker entry point init db. I'm trying to look at that. Yeah, I might have done it wrong if it didn't run that. Docker entry point. Init db.d. Is that how it is? Okay. Yeah, you're right. Okay. Okay, let's try again. I think maybe I can just restart the database and it should work. I don't have to rebuild the entire Docker container. Well, actually, maybe I do need to. Maybe I need to restart Docker. Let me rebuild this. Yeah, I mean, yeah, what am I even talking about? I do need to rebuild because I made updates to the compose file. Okay, let's see. Error mounting. So something was wrong. So it says your path init. Am I missing this? Huh. What's right here? So I wonder what's going on. Does the file need to be init? That's what I'm confused about. Oh, really? Huh. I don't know. I'm just reading the Stack Overflow. What's the time now in my city? It's currently 6:30 a.m. Try init as a folder. Yeah. Oh, okay. So inits. Oh, wait. Yeah. 1 second. Okay. So let me create a file called init. Okay, and then so do I mount the folder into this folder and then it should run it, I guess? When would you use raw queries and or when would you use raw queries and not ORM in a project? I guess if you want more control over querying your data, that's when you would want to use a raw query, or like something like raw queries. But of course, you would want to use prepared statements and not just like actual raw query. Hopefully that worked. No, huh? 2 p.m. here. Yeah, I'm pretty far behind in time. Try now. Yes. Okay. So, I wonder why. That's kind of weird. I didn't do that. Docker entry point init db. Docker entry point init db.d, and then add a file. Okay. So I have. Okay. That's kind of interesting. And I also ran into this con refused. So let me try again. Let's see what's going on. Okay, so these are creating the actual. Yeah, I don't know why it's not working. Create database, Nest.js users, Nest.js payments. Yeah, that's weird. I don't know why that's not running that file. And I have the volume right over here. Huh, that's weird. Init. Create database if not exists, and then use backticks. Yeah, the Stack Overflow does suggest backticks. Let's try that. Let's see. I need to install an actual graphical user interface for MySQL so I can connect to that database. So I don't have to keep on doing this. Nope, still not working. Docker compose. Huh. I'm gonna try one more thing. This might work. Let me try index.sql. And if it doesn't, then I'm just going to forget about this because it seems like it's not working. Well, you know what? Let me go over here. So I can see the index SQL file is right there. Okay, the script is over here. So I'm sure the SQL image should just run it. Nope, I don't know why. Select from Nest.js users. No database selected. Use Nest.js users. Yeah, I wonder why that's happening. Do I need to? You know what I'm gonna do? Let me try this. Let me do this. Let me delete this, and then let me just stop all this. Let me rebuild everything, and maybe that will fix it. Yeah, because that is very weird. But it's okay though if it's not working. It is just so confusing. Let's see. I wonder if it says anything about that index.sql script. Oh, okay. Okay. User bin running. Okay, so it runs the script. Stopping server temporary. Shutting down the server. Server temporary stopped. So it seems like the script is being ran. Nope, I don't know what's going on. Yeah, that's so weird. Don't know about Docker, but will this help? I can't see what you wrote. If you send something, I think it got filtered by YouTube. Because I don't see what you wrote. Yeah, because it does say it's running the script. So I would assume that if it runs that SQL script, that it should be okay. Right? Create database if not exists. So what would be the problem? Let me try. Do I need to put this in quotes? Sometimes it's the silliest things that cause the biggest issues. So if it is really supposed to be because if it's in quotes, I don't even know what to say. I don't see that scripting ran though. Let me see. Nope. Let me see. Volumes init setup SQL Docker entry point. Let me try. Init. I can try renaming it. I'm reading the name file. The name of the file wouldn't matter. Docker entry point. Okay, have that init db. Let's see. Yeah, because if it's just like a regular script for it to run. MySQL Docker container executes script files from Docker entry point in the ascending order of file names. Yeah, I mean, I don't know, unless if something was changed, I don't know why it's, I don't know why this would be any different. I feel like it's just something silly. Set up SQL and then amounts to Docker hyphen entry point hyphen init db dot d slash setup SQL. Unless if there's already a built-in file that is ran that's called setup SQL. I don't know. Let me just try changing this to this. DB data var lib MySQL. What does that one do? Does that mount the database volume or something? I'm enjoying this debugging process. Yeah, it is. It is a lot of stuff to look into, and usually I feel like it is something silly that causes these issues. Just user.p. I don't know, because it is creating this unless, and if it runs it, shouldn't it be created inside? Yeah, like shouldn't. Let me see. Var lib MySQL. Var lib MySQL. I can't really read this stuff, but okay. So Nest.js DB. Okay, hold on. So if you look right over here, I mean, I guess something related is going on over here. I think aren't these like probably like database files? I'd assume. I don't know. Nest.js payments, users, performance. Okay. So let's see. But what would DB data be though? Because I don't have a DB data. DB data. Does it need to be / DB underscore data? I have no clue. Invalid compose project. Hmm. Docker compose. I'm trying to check. Unless if it's creating the database before the servers, even though, but that wouldn't really make any sense because the SQL server has to be up already. Yeah, and we're just creating a database that's in the same SQL server. Excuse me. Sorry about that. Interesting. Yeah, I'm not really sure what I'm doing here. Entry point. Yeah, I mean, I could run a script here. I saw that as well. So this is how a microservice folder structure looks like. Interesting. Each microservice connect to the same DB, right? Yeah, right now it is. Right. What we're trying to do right now is figure out how we can create multiple databases in the same SQL server. So that way I can connect to different databases in each project. But we talked about earlier how there are benefits to sharing a database amongst all your microservices, and there are benefits to having separate databases. What does this do? It doesn't really do anything in particular right now. What we're doing, or what I was doing for the past couple hours, is showing everyone how to set up a microservice in Nest.js and using a combination of HTTP requests and transporting the messages through NATS. By the way, it's nice to see you again, Gareth. I hope you're doing well. Long time no see. Are microservices are microservers? What do you mean by microservers? So microservices are just pretty much like APIs or some kind of process running that can handle, data processing, things like that. It's kind of like an API if you think about it. In our case, our microservice is not necessarily an API, but it is an application that subscribes to um, messages through NATS. I'm okay. I guess I'm tired a lot, but getting there. What about you? Yeah, I'm pretty tired too. It's currently 7, almost 7 a.m. here, and um, I have to go to work in a little bit, in a couple hours. So we were just trying to figure out this issue with why this setup script was not working. Remove one.sql. Yeah, we're trying a lot of different things right now, but not getting much luck. I wonder why though. Um, hmm. Yeah, I don't know why it's still not doing that. It's very weird. Let me see. Because, I mean, what I could do is I could do Nest.js users, and let's just say if I remove this completely. The problem here is that this will not by default create the database for myself. You can see the database doesn't exist. And of course, if I run this in Docker, I want to be able to, let me just try this. I'm going to try using comma separated values and just to see if it works, even though it doesn't say anything about it. I'm just going to try to see because maybe it might work. Each microservice run on a different server. There are situations where you can, um, like for example, if you want to be able to scale, you'll have microservices running on different instances of, let's say, an EC2 on AWS. So something like that. But you can also keep it all on one single server though, if you prefer. But you don't have to run it on different servers. Okay, nope, that didn't work. If my previous message is not visible, yes, I didn't see your message above. So let me see. Uh, volumes. Let's see. Volumes. Let's see. Scripts. Schema. Oh yeah, that's what I saw. Actually, I saw that too on what's it called? I saw that too on some. I think maybe you got it from the Medium post, uh, the Medium article. I think, but I'll try it again. Scripts. Schema.sql. Yeah, I tried that same format, but I'll try renaming everything and see if that fixes it. I don't know if it will, but I'm willing to try. Docker entry point and to be schema SQL. May I ask what the setup SQL file does? So right now we're just trying to get it to create these databases if it doesn't exist. So by default, it's going to create this Nest.js DB just fine because I have it defined in the Docker file. But I'm trying to get it to create these two other databases so we can actually connect to it. Volumes init setup SQL setup SS SQL DB data. Remove / from end. Hold on. What kind of microservice is this? Nothing in particular. I was just showing everyone how to build a microservice with NATS and TCP protocol. Okay. I mean, unless if the database is there, but it's just not showing up for some reason. I mean, I can try logging in as the root and see if that helps. Maybe for some reason test user just can't see the database, even though it should. Okay, so I guess it's there if I log in as root, but what if I logged in as test user? Okay. Okay, yeah, so it seems like test user does not have permissions to see the actual database, which is very weird because I mean, I guess that I created this. I mean, I can also just grant the permissions to test user. Why don't I, okay, yeah, so the script actually works. So what we were doing, I'm sure all the variations that we tried worked. It's just that it was a permissions issue from what it seems like. Which is okay. I can fix that right now. Yeah, so the script, it seems like the script did work. It's just that we need to grant the permissions. So let me do this. Grant all privileges on to test user at. Hopefully this will work. But that is weird though, because I thought that this would create a root user. Maybe not. Let me see. Docker MySQL. Let me look at the docs again for that. Let's see. Maybe not. So we do have to grant the privileges. But when I read this, but here, I guess this is what I understand. This user will be granted super user permissions for the database specified by the MySQL database variable. So we're our super user. But yeah, if it's a super user account, shouldn't it be the same permissions as root? Hey Ibrahim, how are you, man? It has been a while. How are you? Wish Solidor, how are you? Welcome to the stream. Yeah, it has been a long time. I hope you all are doing well. It's been a year actually. I hope you guys have made a lot of progress with your coding journey. You know, I hope you guys have, because I remember a year ago, a lot of people were asking me like some questions on how to get started with this and that. So yeah, I hope you guys are doing well with that. Okay, let me try restarting this again, and hopefully this works. There's one more thing that I did want to do though that I forgot about. Let me go back into the compose, and I think I need to set users, microservice, and payment. So I need to do this depends on MySQL DB. So I think, let me actually read. Like I said, guys, I'm pretty new to Docker as well, so that's why there's a lot of things that I have to look up and read about. So let me read about this. So depends on express dependency between services. Service dependencies cause the following behaviors. Starts service independency order. So yes, that's what I wanted, because I don't know if you guys noticed, but when I was running the Docker Compose script, it kept on saying that it cannot connect to the database, and that's because the SQL Server was not up yet. So I need to set that depends on. So yes, it will run in the correct order, and then it will automatically include service dependencies and Stop service dependencies in dependency order. Okay, yeah, so that's exactly what I want. You planning on doing another Discord dashboard? You know, it's been such a long time since I've actually worked with Discord API stuff. I kind of got discouraged from working with Discord stuff because they changed the API so much, and the direction that Discord is going is that they're making it less creative for developers, because now everything is done through. I mean, I don't really use Discord much anymore. But the last time I saw Discord, they have like a bunch of these built-in stuff like slash commands, user interactions, and they have a lot of other features um that are just kind of like already part of Discord that made a lot of existing bots obsolete. So I don't know. I mean, I would have to do a lot of maybe I don't know. Maybe I'm ignorant and I don't know much about it right now, but I do have to do some research about it. Not saying that I won't, but I would have to see what they have changed and see what I could develop in a way that would make it, appropriate for that. You helped us a lot when you used to build this chat room app. Yeah, I appreciate that. Thank you. Working with Go, Python, TypeScript, always wanted to come back to Discord bot development, but ain't got time. Yeah, they are implementing features we love to develop and think about. Yeah, they really have changed a lot. I don't know. I mean, I gotta read the docs again because I haven't really done much with Discord. Um, okay, so let me just add this depends on for both of this. We don't need to do it for root API because root API is not really gonna make the database connection. It's just our microservices will. The root API is kind of like a pass-through layer if you think about it. It's like a middleman if you want to put it that way. So now if I run this Docker compose script, I shouldn't get that database error anymore. Okay, perfect. Yeah, no, you'll notice how I just ran the database and then it runs these microservices. So okay, let's see. Let's go back here. MySQL test user. Okay, so did that not work or what? Oh wait, it's the wrong file. Whoops, I had the wrong file. Okay, so it's scripts. I only have one, so I'll just leave it like this for now. Oh, actually, I don't even need this part. Okay, should work. Where are you from, Sty? Well, I'm from New York originally, but now I'm in Arizona. What's going on over here? Do I really need this / Let me see. I guess I need this. Yeah, I'm from Phoenix. Okay. Please. I hope this works. Interesting. Grant all privileges on, okay. To user at this. Grant all privileges on. So this is for all databases, isn't it? Grant all privileges on databases to test user. Am I missing something? I think I'm missing. Do I need to flush privileges? I mean, unless if the user is, because the user is being created in here, so, let me see. Is there like a script that I can run before? I mean, it's doing this. Am I enjoying living here in Phoenix? Yeah, I like it here a lot. I currently work here, so it's really nice. It gets cold during this time, but it's not as cold as the East Coast, like in New York City. Grant all privileges on. Okay, I have that. Grant all privileges. I spelled that correctly. Privileges on to test user at Okay. I wonder why that's not working. Do I need to create the user? Do I need to grant the privileges first? And then do that? I don't know. Because the databases are being created, it's just that my user account that I'm logging into, it can't see, it doesn't have permissions to see those databases. I don't know why, but gotta work by. All right, have a good one. I hope you enjoy it. I hope you enjoy work. No. I mean, what if I did this? What if I did? Grant all privileges on. Let's see. Grant all privileges on to test user at. Okay, so now I can see it. So, okay, so I did use the correct script. Maybe I gotta flush privileges, I guess. I don't know. I'm willing to. This is what the debugging process takes. Create user root at localhost. Oh yeah, I already have the root user created already. So maybe this is what it takes to debug is patience. And with patience comes bigger rewards. So let's see if this works. Okay, now it works. Perfect. Okay, so it was the flush privileges script, or yeah, this SQL script that we needed to actually save the changes, I guess. So, wow, we finally figured it out. Okay, there we go. So now that we've done that, we can actually finally connect to different databases because we have Nest.js payments, Nest.js users. So what I'll do is now I'm going to go into, let me do this. Let me move this into init because I want all of my projects to kind of like be over here. I kind of want all the projects to be together. I don't want it to be like separate. I don't know. I don't even know what I'm saying. I'm just change it back to init and change this to init schema. Okay. Okay, so let me go into payments microservice. This is where it connects to the database. SQL looks so confusing. I use Mongo. Yeah, sometimes it can be pretty confusing because of all of the queries and such. But you know, honestly, if you use ORMs, it makes it so much easier. Whether you use whatever database, so that way you can actually make your queries in the actual code instead of actually having to write the actual query language. So what I'm going to do in the payments microservice is I'm going to switch the database to Nest.js payments. Okay. So our payments microservice should be able to connect successfully. And then let's go back to the users microservice. Let's change this to Nest.js users. And then the users microservice should have restarted. There you go. Yep, it restarted. And let me just make sure that that is the correct database name. Nest.js payments, Nest.js users. Okay, so now we have our microservices connecting to a separate database. Okay. So here's what we're going to do. Here's what we're going to do. 1 second. Sorry, I just have to send a text. Okay, so what was I saying? So right now our payments microservice has its own database. It's in the same database. It's using the same database server connection, but it just has its own dedicated database, and it'll have its own tables. Okay. Same thing for the users microservice. But I'm only showing this as an example. It is kind of overkill to have a database with only one table to store everything when you can just have it all in one single database. But I am just showing this just for demonstration. Okay. But okay, so let's go over to user microservice, and user microservice is connected to its own database. So what I can do now is I can create users and I can create payments. So let me create a user right now. I just create a user, and let me create a payment. Just create a payment. Now, if I go into MySQL, what I can do is I can use Nest.js users, show tables, select asterisk from users, and now you can see that inside my Nest.js users database, I only have one table, and then I have the database record over here, the table record right over here. So if you needed each individual database for each microservice, this is one thing that you could do. Let me step into the payments database, select asterisk from payments. You can see the payment is there. Show tables. Only one table is there. Okay. Now the question becomes, well, what if you have a situation where you have a user's payment record that is completely in its own database? So for example, let's say this payment is related to this user. How would you retrieve that? So this is where you need to make sure that when you create a payment record, you actually also have the user. You have some information, typically a unique value that represents the user, attached to that record, so that way you can use that to reference the user. But again, if you're using a relational database like SQL, you're better off just using a shared database and using a join to join everything together, because it just doesn't make sense to do it this way. I can understand if you're using, let's say, MongoDB. I mean, even with MongoDB, I still wouldn't think you would need to use a separate database. But there are situations, just not in this one, there are situations where you do specifically need separate databases. Maybe sometimes you might have a SQL database for all the main data application, and then you might have a database just for like smaller parts of the application that uses MongoDB. And then the MongoDB document would need a reference to some record, like, so it would need like a user ID, and then you would have to use that user ID to fetch the correct document. So I know it's a lot, but hopefully that makes sense. Okay. But yeah, so that's gonna be pretty much it. I know I only intended to stream for an hour and a half, but that's okay. I wanted to show you all a lot of stuff of what was going on. What I'm gonna do though is I am going to upload all this code that you see here in a GitHub repository, because I think we've done a lot of work to have it not be on GitHub. So if any of you want to use this as a reference to either, maybe try it out yourself, see how it works, play around with it, maybe even build your own project on top of this, then I highly encourage you to do that. Okay. I'll have this, I'll probably, what I'll do is once I have some time, I will put a README here, and then I'll push everything to GitHub, and then I'll leave a link in this live stream description so you all can actually use it as a reference. Okay, but yeah, I'm gonna head off because I gotta get ready for work. But thank you everyone for joining my stream today. It was nice seeing all of you again, and for those of you who are brand new, it was nice seeing you all as well. I'm gonna be heading off right now. I do have a new video, like I mentioned before, on Nest.js for with MongoDB. It's gonna be a Nest.js, MongoDB, and Mongoose tutorial, 2-hour long video that has a lot of stuff in it that shows you just how to do a lot of different things with MongoDB. So if you guys are interested in that, check that out. It's going to be on Friday is when it will go live. So I will see you all either in my next video or in my next live stream.